Let's review the electrical installation plan for adding drop cords in a warehouse to supply power to a small office. The plan involves running a circuit from a double 20-amp double-pole breaker in the panel, then through conduit across the warehouse ceiling, down to a series of junction boxes, and finally to drop cords with 2 GAN junction boxes for power distribution. The plan proposes using 4 number 12 copper wires, 2 black, 1 white, and 1 brown. We will evaluate the plan, providing considerations for safe and code-compliant installation. Firstly, let's discuss conduit sizing. For a 20-amp circuit with 4 number 12 copper wires, a half-inch conduit is generally sufficient according to the National Electrical Code. However, it's crucial to consult the specific conduit fill tables in Chapter 9 of the NEC to ensure compliance based on the exact type of conduit being used. The NEC provides tables for different conduit types, such as rigid metal conduit, electrical metallic tubing, and PVC conduit. These tables specify the maximum number of conductors allowed in a given conduit size. When selecting the conduit size, consider not only the current number of conductors but also the potential for future expansion. It might be prudent to upsize the conduit to accommodate additional conductors if future needs are anticipated, making future modifications easier and avoiding the need to replace the conduit later. Secondly, let's address junction box placement. The plan includes using 4 S-junction boxes for the initial connection point on the ceiling, at the lower point before the drop cords, and for the 2 GAN boxes and the drop cords themselves. The 2 GAN junction boxes in the middle of the drop cords are appropriate for supporting the weight of the cords and providing a disconnect point. Ensure that all junction boxes are securely mounted to the building structure and that the drop cords are properly supported to prevent strain on the electrical connections. Consider using strain relief connectors where the drop cords enter the junction boxes to further reduce the risk of pulling on the wires. Thirdly, consider the voltage drop calculations. For a 20-amp circuit, the voltage drop over 85 feet, which is 15 feet plus 20 feet plus 50 feet of number 12 copper wire, is generally negligible. Therefore, detailed voltage drop calculations may not be strictly necessary. However, it is always a good practice to perform a basic voltage drop calculation to confirm that the voltage at the final point of use is within acceptable limits. The NEC recommends a maximum voltage drop of 3% for branch circuits and 5% for feeders. The voltage drop can be calculated using Ohm's law and the resistance of the wire. For number 12 copper wire, the resistance is approximately 1.98 ohms per 1000 feet. Using this value, the voltage drop can be estimated. If the calculated voltage drop exceeds the recommended limits, consider using a larger wire size to reduce the resistance and improve the voltage at the point of use. The NEC provides guidelines for voltage drop calculations in informative Annex C. Using number 12 American wire gauge copper wire for a 20-amp circuit over a total length of 85 feet should generally result in acceptable voltage drop, assuming a standard 120 volt supply. However, calculating the expected voltage drop is essential to guarantee efficient performance of the electrical equipment. Voltage drop occurs because of the resistance of the conductors, which causes a reduction in voltage along the wire length. The formula for calculating voltage drop is voltage drop equals 2 times the length in feet times the current in amps times the resistance per foot of the wire. The resistance per foot for number 12 American wire gauge copper wire is approximately 0.198 ohms per foot. So, if we have a 20-amp load and a total wire length of 170 feet, that's 85 feet for the hot wire and 85 feet for the neutral wire, the voltage drop would be approximately 6.73 volts. Now, let's calculate the percentage voltage drop, which is the voltage drop divided by the source voltage times 100. Assuming a source voltage of 120 volts, the percentage voltage drop would be approximately 5.61%. This is slightly above the recommended maximum of 3% for branch circuits. To reduce the voltage drop, you could consider using number 10 American wire gauge copper wire, which has a lower resistance of approximately 0.124 ohms per foot. We're calculating with number 10 wire. the voltage drop would be approximately 4.22 volts, and the percentage voltage drop would be approximately 3.52%, which is closer to the recommended limit. Alternatively, if the load is not continuous, meaning it doesn't operate for 3 hours or more at a time, the voltage drop may be acceptable. Continuous loads require more stringent voltage drop calculations because they can cause overheating and reduce the lifespan of electrical equipment. In EC section 210.19, 8.1, informational note number 4 provides guidance on voltage drop and recommends that the voltage drop on the branch circuit should not exceed 3% and the combined voltage drop on a feeder and branch circuit should not exceed 5%. This is only a recommendation, not a mandatory requirement, but it is a good practice to follow to ensure optimal performance and longevity of electrical equipment. To further mitigate voltage drop, consider minimizing the circuit length whenever possible. Routing the conduit in a more direct path can reduce the overall wire length and, consequently, the voltage drop. Additionally, ensure that all connections are tight and properly made to minimize resistance at connection points. Loose or corroded connections can increase resistance and contribute to voltage drop. Using high-quality connectors and terminals can also help improve the reliability of the electrical system. Furthermore, consider the impact of voltage drop on the performance of the electrical equipment being powered. Some equipment is more sensitive to voltage variations than others. If the equipment requires a stable voltage supply, it may be necessary to use a larger wire size or a voltage regulator to ensure proper operation. Voltage drop can also affect the efficiency of the electrical equipment, leading to increased energy consumption and higher operating costs. Therefore, addressing voltage drop is not only important for safety and reliability, but also for energy efficiency and cost savings. In summary, while the voltage drop for a 20 amp circuit with number 12 copper wire over 85 feet may be negligible in many cases, it is always prudent to perform a basic voltage drop calculation to confirm that the voltage at the point of use is within acceptable limits. If the calculated voltage drop exceeds the recommended limits, consider using a larger wire size, minimizing the circuit length, and ensuring that all connections are tight and properly made. By addressing voltage drop, you can improve the safety, reliability, and efficiency of the electrical system and ensure optimal performance of the electrical equipment being powered. Additionally, let's examine the overcurrent protection. The plan specifies a double 20 amp double pole breaker at the panel. This is appropriate for a 20 amp circuit using number 12 wire. Ensure that the breaker is correctly sized for the wire gauge to prevent overheating and potential fire hazards. The NEC specifies the allowable ampacity of conductors based on their size and insulation type. For number 12 copper wire with typical insulation, the allowable ampacity is 20 amps. Therefore, a 20 amp breaker is the correct choice. It's crucial to avoid oversizing the breaker, as this can allow excessive current to flow through the wire, leading to overheating and potentially causing a fire. The breaker should trip and interrupt the circuit in the event of an overload or a short circuit, protecting the wiring and equipment from damage. In addition to the breaker, consider using ground fault circuit interrupter protection for circuits serving wet or damp locations, such as areas near sinks or outdoors. A ground fault circuit interrupter detects small imbalances in the current flowing through the circuit and quickly interrupts the power, preventing an electrical shock. GFCI protection is required by the NEC in many locations to enhance electrical safety. When installing the breaker, ensure that it is properly labeled to indicate the circuit it protects. This helps facilitate troubleshooting and maintenance in the future. The panel should also have a clear and up-to-date circuit directory that identifies the loads served by each breaker. Proper labeling and documentation are essential for maintaining a safe and organized electrical system. Moreover, let's discuss wiring methods. The plan involves using conduit for the majority of the circuit run. Conduit provides excellent physical protection for the wires and helps prevent damage from impact or abrasion. It also provides a path for future wiring upgrades or modifications. When installing conduit, ensure that it is properly supported and secured to the building structure. Use appropriate conduit fittings and connectors to create a watertight and secure raceway. Avoid sharp bends in the conduit, as these can make it difficult to pull wires through. The NEC specifies the minimum bending radius for different types of conduit. When pulling wires through the conduit, use a wire lubricant to reduce friction and prevent damage to the insulation. Avoid overfilling the conduit, as this can make it difficult to pull wires and can also reduce the ampacity of the conductors. The NEC specifies the maximum allowable fill for different conduit sizes. Consider using colored wires to identify the different conductors in the circuit. This can help simplify troubleshooting and maintenance in the future. The NEC specifies the standard color coding for electrical wiring. Black is typically used for the hot conductor, white for the neutral conductor, and green or bare copper for the grounding conductor. Proper wiring methods are essential for ensuring a safe and reliable electrical system. Adhering to the NEC guidelines and using high-quality materials and workmanship can help prevent electrical hazards and ensure that the system operates properly for many years. Furthermore, let's discuss grounding and bonding. Proper grounding and bonding are essential for electrical safety. The grounding system provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and clear the fault. The bonding system ensures that all metal parts of the electrical system are electrically connected, preventing voltage differences that could create a shock hazard. The plan includes using a ground wire in the circuit. This is essential for providing a low impedance path for fault current. The ground wire should be connected to the grounding electrode system at the service entrance. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. When installing the grounding conductor, ensure that it is properly sized and connected to all metal enclosures and equipment. Use appropriate grounding connectors and terminals to create a secure and reliable connection. Avoid using the neutral conductor as a grounding conductor, as this can create a shock hazard. The NEC prohibits the use of the neutral conductor as a grounding conductor in most cases. In addition to the equipment grounding conductor, consider using a supplemental grounding electrode at the location of the drop cords. This can help improve the overall grounding system and reduce the risk of electrical shock. The supplemental grounding electrode should be bonded to the equipment grounding conductor. Proper grounding and bonding are essential for protecting people and equipment from electrical shock and fire hazards. Adhering to the NEC guidelines and using high-quality materials and workmanship can help ensure a safe and reliable electrical system. Finally, let's address the forum usage. The forum is a valuable resource for electrical professionals to ask questions, seek help, and share knowledge. Feel free to use the forum to clarify any doubts or concerns regarding the installation plan. It's a great way to get feedback from experienced professionals and ensure that the installation is safe and code compliant. The forum also provides a platform for discussing best practices and learning about new technologies and techniques in the electrical field. Take advantage of this resource to enhance your knowledge and skills. In addition to asking questions, consider contributing your own expertise and experience to help others. Sharing your knowledge can benefit the entire community and help promote electrical safety. The forum is a collaborative environment where professionals can learn from each other and stay up to date on the latest developments in the electrical industry. Remember to follow the forum's guidelines and etiquette when posting questions or responses. Be respectful of others and provide clear and concise information. This will help ensure that the forum remains a valuable resource for everyone. Moreover, you can add pictures to your questions by using the Add Image button in the text editor. There is no limit on the number of pictures you can add. Including pictures can help clarify the situation and provide visual context for the questions. This can make it easier for others to understand the problem and offer helpful solutions. When adding pictures, ensure that they are clear and well lit. Use appropriate file formats and sizes to ensure that they can be easily viewed by others. Crop the pictures to focus on the relevant areas and avoid including unnecessary details. Adding captions or annotations to the pictures can also help explain the situation and highlight important features. Visual aids can be a powerful tool for communicating complex information and improving the quality of your questions. Lastly, you can use your website to share information and resources related to your questions. However, it is generally not advisable to direct users to external websites without providing a clear explanation of why it is relevant to the question. Providing a brief summary of the information on a website can help users determine whether it is worth visiting. Avoid using your website for self-promotion or advertising. The primary purpose of the forum is to share knowledge and help others, not to promote personal or commercial interests. If you have valuable resources on your website that you believe would benefit the community, consider summarizing the information and posting it directly in the forum. This will make it easier for others to access the information and participate in the discussion. In conclusion, the electrical installation plan for adding drop cords in the warehouse is generally sound. By considering the conduit sizing, junction box placement, voltage drop, overcurrent protection, wiring methods, grounding and bonding, and forum usage, you can ensure safe and code-compliant installation. Remember to consult the NEC and other relevant standards for specific requirements and guidelines. By following these recommendations, you can create a reliable and efficient electrical system that meets the needs of the warehouse and the small office.